Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, and I welcome you. We have a great webinar on tap today, but before we get started, we do have a few housekeeping items. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is preventing code leaks and other critical security risks from code. Our speaker today is Ajay Arora, who is President and CEO of Blue Bracket. Ajay, thank you so much for joining me today. Really appreciate it.
Thank you so much for having me. I'm looking forward to it.
All right, all right. Well, I know you've got a great presentation on tap, so I'm going to put myself on mute and let you get right to it.
Okay, awesome. Thank you so much. And hey, good afternoon, good morning to everyone, wherever you might be, and looking forward to the webinar. So we'll be talking about a subject that's near and dear to my heart. And it's really want to be able to dive into what is emerging as one of the biggest and newest threats that especially as we're in this completely new age of everything being driven by software. And so we're going to be talking about preventing code leaks, other security risks that are imposed by source code, as really kind of the next front on this war, or whatever you want to call it, or surface area of attack on cybersecurity. So I'm going to go ahead and dive right in, and we'll, as mentioned, please go ahead and enter any questions. We'll get towards them at the end. And so we're scheduled for about an hour. I believe in brevity as much as possible. At least I try to follow that. So we're going to try to make this as painless as possible and get through the material at a decent rate, and then we'll open it up for questions. So we'll start talking very briefly, promise you very briefly, about me and as to why you should be tuning in and listening to me on this topic. And then we're going to go right into it. We'll talk about why is source code security important, and why is it especially important now? And then get into the topic of what are the threats that are there really from source code, based off of not just what's come out of my head or my colleagues' heads, but really after speaking to lots of industry veterans and probably 100, 150 companies or more, big and small across the board, multiple different verticals. And then, of course, some strategies to be able to address these threats, and then go into Q&A. And so with that, let me just give a little brief intro of myself. I'm what you guess you'd call a startup or a cybersecurity junkie. This is my 3rd company that's dedicated to cybersecurity. It's the 3rd company that I've co-founded from that perspective. If you want, please feel free to reach out to me via Twitter at my handle, or via my email. It's very simple at aj@bluebracket.com. So one thing this is not going to be, I want to make sure that you understand that this is not a sales pitch in any way, shape, or form. We're going to talk about all this agnostic of any kind of product. Obviously, there's tools and there's solutions that can be employed here, but in terms of talking about the threats and talking about the actual solutions, the strategies that you can take, please be aware that we're not going to be advocating or pitching any tools one over another. So with that, we'll go ahead and jump in. And so let's start with a statement that everyone is kind of very familiar with, at this point, and it even seems a little bit trite. Software has really eaten the world, and the reason why that's important to restate is that even companies that you may not traditionally think as people that are dependent upon, or their product is software really drives and impacts every single business and impacts every single one of us, right? So, for example, Domino's Pizza happens to be a logistics company that has highly optimized software algorithms that they just happen to sell pizza, right? So there's a lot of different companies that fall into that. And so software is so critical to the aspect of it. And underlying all software is source code. And source code is critical to the operation and enablement of software. So why has this become important from a security standpoint? But so let's take a little bit of step back and put this into perspective. So source code management, source code development, software development has gone through multiple generations of progress over the number of the last decades, and it's been around forever. So why is source code security so important now? So if we think back, when you think about source code management and the development of software, let's think about how source code was managed. People use tools like, and they still do today to some extent, like Perforce, SVN, CVS, all these different tools that you might be familiar with. And the common denominator among those were they were generally monolithic, they were centralized, and they were tools that were generally behind the firewall in complete enterprise control. And they offered lots of visibility and control for the enterprises that controlled them. The negative side of it was, from a development standpoint, it was slow in terms of being able to push out software. So the idea is that developers could only check in or check out portions of code that they're working on. And there were race conditions and sometimes a lot of different conflicts in being able to push through things to the development cycle. And there was no real CI/CD cycle that happens in a very accelerated, way that we see now. So the whole world has changed, and there was a backlash to this from these different source code management systems. And if you look at software development now, the way that software is built has basically changed forever. It's far more distributed, collaborative. People pull and contribute to open source, very, very openly and easily. And a lot of the software that's being developed is actually developed and deployed, in many cases, cloud native or in a hybrid sense. And underlying this kind of revolution has been Git. Git, as we all know, is a protocol and is not manifested in any single product. But if you look at the bottom here, there's 3 main vendors in the world of Git: GitHub, Bitbucket, GitLab, that control about 90% plus of the software source code management that's out there. And in this world now, we've gone from this monolithic centralized management of source code to a world where developers actually own the process. And so no longer can they only just check out pieces of code, they get to check out the entire source code repository. They get to spawn different repositories that are out there. In fact, in organizations, some have dozens of repos, some have hundreds. We even dealt with customers and prospects and companies that have thousands of different repos that are out there, and not with a lot of consistency across it, et cetera. But the underlying characteristic from a developer standpoint is that they get to go ahead and clone or copy all the source code that they need, execute and develop remotely. And it makes it very easy for them to be able to develop software. The flip side of that is, if you think about it, we've gone from an enterprise standpoint, from being in a world where only developers could check out portions of code and only have visibility of pieces of code at any given time, to a world where once that source code is pulled onto their device, the enterprises lose all control. And the security, visibility aspects of being able to manage source code have forever changed, and the balance of power has forever changed. So whether people like it or not, what we're seeing is that source code is everywhere. And if you think it's still nicely controlled, behind your firewall, it isn't anymore. It's everywhere, and enterprises are, fundamentally at risk from the fact that you can find source code on developers' laptops, their desktops. If you work with consultants or third parties, it's on their machines, on their networks, on their servers, and consultants and contractors generally work with multiple different parties, right? There's public source code management and sharing sites. There's github.com, there's Stack Overflow, there's Pastebin. There's all these different enabling technologies and tools that make software development easier, but also at the same time simultaneously are making it more difficult for organizations to manage their risk as it comes to managing source code and the visibility and access to that source code. And open source is such a wonderful thing. It's made all our lives easier. But imagine a lot of enterprise, a lot of your crown jewels, or even your other source code sometimes makes it into, and more often than not, makes it into these open source projects, right? And so this is where the risk kind of emerges, and this is what we're going to talk about in terms of what are those specific risks when we double click on that. But the idea here is that code is everywhere, and definitely hackers have noticed. And it's opened this new surface area of vulnerability or attack, or in the war on cybersecurity. So if you think about, let's make an analogy. If you think about email, right, not people really don't care much about what is in the majority of email that's out there, right? But what's the #1 vector of attack into an enterprise at this point? It's phishing attacks. And it's a vector of attack. Source code is becoming that vector because source code goes along an entire CI/CD cycle from design, develop, to build, to ship, to run. And at any one of those points, that source code is vulnerable. And there's no turning back from this as well. In the last year, there's been more Git repositories and Git users created than probably, and then this last 6 to 8 years combined. So even the most sensitive organizations that you'd think from a security standpoint have now moved, whether they not like it or not, into this world of Git. And so we see this now emerging in the kind of hacks that are going out there. So in 2019, for example, almost 50% of all breaches came from the misuse of credentials. And a lot of times these credentials are found in code. Here's just a few recent examples of this. There was a report that was issued just a little while ago, a few weeks ago, I think it was around Black Hat, in which source code from 50 extremely well-known companies were found or to be leaked online. In the last few weeks, Intel experienced a leak where terabytes of data or gigabytes of data, hundreds of gigabytes of data were actually put online into public GitHub.com. So companies across the board are finding that their code and everything that else that could be in Git is actually making it into a lot of these publicly shared websites and publicly accessible websites, right? So with that, I think that's a great transition point to talk about what are the top threats that companies face, that enterprises face, and what to do about them. And we'll use examples for each of these as well. So by far, in every single situation, in every company that we've spoken to, one of the biggest problems is that there are secrets, credentials, passwords, tokens, API keys found in code. Source code, we have to remember, it's very leaky, especially when it's in Git. Code can be copied and transferred everywhere, and Git is designed in a way that allows and even promotes code to be freely distributed. So projects can be cloned onto multiple machines, forked into new projects, distributed to the customers, made public, and so on. And each time it's duplicated on Git, the entire history of that project is also duplicated. And as such, the passwords, tokens, etc., are also duplicated as well. There's estimates that upwards of 1% of all check-ins have some kind of password or secrets or credentials that are in code. 1%. So if you think about the millions of check-ins that are made each day, that's a huge number. And then you compound that over years, and that becomes problems. In fact, we've had customers and prospects or people that we've spoken to that have found secrets that have come back to bite them that have been as old as a decade or more that were in code. And you'd think that people would rotate those keys, etc., but that is something that they don't do. And it's become such a problem that there are people out there that are writing literally cookbooks on how to be able to go and exploit these tokens, these credentials, and these secrets in code that are out there, right? So, some of you might know that there's this renowned hacker out there named Ghost Lulz, that he has what he calls a hacker army, and he's actually issued instructions to his army of followers out there on how to exploit Git, and specifically in this case, GitHub. It could be GitLab, it could be Bitbucket. You take your pick on how to use these various source code management and sharing platforms to be able to get access and exploit these different systems. So, as he states, people are always uploading sensitive files to GitHub, and it's not just code. There's all kinds of other artifacts. And in the case of Ghost Lulz, he once performed a pen test against the company, and he was able to find and expose a history file which had all these SSH passwords. And he's personally been able to go in and exploit different servers and boxes that he's found on GitHub. And if you take this and you multiply that by the number of different repositories that are out there in the Git universe, it becomes a massive problem. So it's not only a problem to have these secrets and credentials as bad policy within an organization in your enterprise repositories, but imagine the problem it creates when it exacerbates and it goes into that overall public universe that's out there. And so, another example of this is just a few months ago. In this case, a white hat ethical hacker found that a jump cloud key for, in this case, it was Starbucks, and it could be any one of us, available publicly on GitHub. And with this key, the hacker could go and add and removers and gain access to Starbucks internal systems. So it's not only just being able to get access to different API or infrastructure services or not, but being able to hijack credentials to be able to get into internal systems. And so, while going through the GitHub search, they discovered a public repository which would include those keys, and the impact it's critical, right? Anyone could imagine. They were able to execute commands on the systems and add or remove users which had access to the internal systems. So the impact is rather profound, from that standpoint, right? So this is by far the #1 concern that we've seen in organizations in terms of the secrets and passwords that are sitting there within code. So #2, now we talked about the fact that in this new world of Git, developers are able to go and clone code onto their devices. And once they clone that code, there's a kind of curtain that's been drawn up where the enterprise loses kind of visibility of all that code. So as we said, by nature, Git is open, permissive, and it allows for this cloning of code by practice and promotes it to make it easier so developers can go ahead and develop in a remote fashion. And so the status quo and the way the industry is right now, companies have little to no idea who has cloned their code, where their code lives, and even has access to it. And so this is not just your internal personnel, but anyone who's working with contractors or third-party organizations as well have, there's not just this contained circle there. There's multiple circles of visibility. Internally, third-party collaborators and contractors, all the way to the open source ecosystem or the public ecosystem that's out there. And without visibilities, companies can't track malicious insider threats or know if contractors or employees have uploaded important intellectual property or code to their servers or open source. And fundamentally, you're not able to secure what you can't see. And this brings up another really important point is that not all of this is actually malicious actors that are involved in being able to do this. So when we hire developers, when you hire developers, their street cred, their CV, their resume is not LinkedIn. It's their Git persona, their Git handle, what projects they've contributed to. And so a lot of times developers view themselves as craftsmen. They develop their code, so they'll take that code and they'll upload it to their personal Git repos and highlight it. And I've interviewed developers who very openly talk about the code that they've developed in past companies, and they don't do it in a nefarious way. They do it in a very matter-of-fact way of saying, hey, I worked on this, here's an example, not knowing intentionally that they could be putting their past enterprises, employers, at risk. So this is a very pervasive problem. It's not just about insider threats. It's about anyone who's being able to get access to that code, and even in a non-nefarious way, being able to do this. So when we visit this in, again, let's go back to our example here of our favorite hacker, Ghost Lulz. He's actually given detailed instructions on how to be able to exploit the fact that so much intellectual property and code has made it into these public repositories that exist outside of enterprise repos. And there is a laundry list or a cookbook on how to be able to do this. First, you find a company's GitHub page, and from there you can locate all their developers and monitor those accounts. And it's been a long time since I've been a developer, but even I can go in now very easily into github.com or any of these public sites and be able to find any company's GitHub page. It's very easy to search for it and be able to find it. So you locate it and you monitor their accounts. Once you find a company's page, you just get a list of the people that are associated with that company. This can be done by clicking simply on the people tab that's out there. And once you do that, now you'll know you just go manually through each one and look for exposures. Should be looking for URLs, and they can look for API keys, username, password, other vulnerabilities, and anything else that could provide value. And because companies don't track developer endpoints or their personal repositories or personal contributions, they are completely blind at this point in terms of being able to see what code might have exfiltrated out into the public universe. And again, it's not to say that any of these developers are doing this in a nefarious way. They're doing it in a very matter-of-fact way. And this leads to this kind of exposure and this risk, right? So this is something to definitely take care of. So it's in addition to secrets and code. The second one is this code and the lack of visibility into this code and making it into these public environments is a big problem that we're facing today. And it's only getting worse as people become more and more reliant on code, and code multiplies exponentially. The third threat is we all love open source, and no one starts with a blank slate anymore as it comes to development. In fact, there's some statistics that say over 97% of applications have some level of open source within it. And what you put that number at 80%, 90%, 97%, it doesn't really matter. It's a lot of code that has open source built into it. And so while a lot of companies, and most companies in fact, will have an open source policy, it's not something that's necessarily enforceable. Policies are very notorious for obviously being broken, and again, not necessarily in a bad way or not in a way that people are trying to be bad citizens, just because it's just there's no enforcement mechanism that's programmatic there to be able to do it, and make it easier for developers to use. And developers want to focus on getting their job done. So hackers are getting more sophisticated and replacing these open source libraries and packages and creating backdoors into a company and their product infrastructure by these exploits. And if you imagine when you have these open source packages and then vulnerabilities get introduced, and when they're downloaded, it's viral and they propagate and they can infect many, many, many companies without you even knowing, right? And they'll frequently do this by brute force attacking Git repos or social engineering against product developers. And in 2019, backdoors were stuck into 12 open source projects and downloaded hundreds of thousands of times. That's just one statistic that that's out there. And here's another, just 3 examples of open source, specifically GitHub in this instance, of these projects being hijacked by hackers for botnet farms or ransomware. They all gained access to their GitHub account and replaced the write files with malicious files. In the case of some of these, they've multiplied many, many hundreds of thousands of times, and most people aren't even aware of what's happening and the fact that open source is being used, because they only enforce this by overall policy. And so in 2019, another example is there was a takeover of the Ruby Gems package. Hackers brute forced a developer password and inserted a backdoor into the very popular strong password Ruby package. And the infected package then would be inserted into code and allowing for remote code execution, which is a huge security hold, obviously. And it's something that is can have profound effects. And in the case of what was going on here, the hacker literally cracked an old password of this developers before they were using 1Password that leaked who knows when, from which various breach in years past. So it definitely came back to haunt them. So the exploit of these open source projects and these packages is definitely a main area of concern as it comes to code and making into that part of your bill of materials in your code. So in addition to secrets in code, the lack of visibility and proliferation of code, the fact that you need to be able to manage very closely of malicious code that can come, and understanding where your open source is a huge problem as well. Number 4, and we're getting to the last 2 major areas of vulnerability here, right? So here's a very important thing to realize. Git at its heart is really a version management system, and it's used not just for traditional code, C, Java, C++, R, whatever it is, Python. It's not used simply for code. People are using it for managing multiple artifacts, right? And so two of the new areas that are emerging from this are things that we refer to as infrastructure as code or policy as code. And infrastructure of code is literally what it says. It's basically a blueprint of your entire network and infrastructure, and it's being managed often along the CI/CD cycle within these different Git repositories. And when it comes to this infrastructure as code, your code shows which application servers, source services, and others are used in your stack. And the information gives hackers a detailed map of which vulnerabilities to target. So infrastructure as code, and then more advanced and newer is also this idea of policy as code, which means your code holds even more valuable information, not just of the applications or the software you're building, but the infrastructure in which it runs, especially this web-based infrastructure that's out there. And code can also give, to be honest, competitors a way to gain advantage against you by understanding where your vulnerabilities are, where you're weak in your infrastructure and your scalability, things like this. And we've seen this a lot more. So if you're using things like HashiCorp's Terraform or others, this becomes a major problem. And so if the 787 already didn't have enough issues, recently a security researcher found an open server on Boeing's network that contained a huge amount of code for its 787 aircraft. And with this information, in this case, it was an ethical hacker, disclosed how to target the network systems, and the code gave him, and thankfully this was an ethical hacker and not a black hat, a roadmap to exploit and target vulnerabilities in airplanes' critical systems. And these vulnerabilities were all exposed from code, not from other data, not from files, not from unstructured data, not from databases that we're traditionally aware of, not from other things. All these exploits came from source code. And again, this is non-traditional, what you expect, but this gave a massive insight in there. And so you can see how these threats keep compounding. And this gives a good segue into our last threat that we're going to talk about here as well. And then we'll get into talking about how to be able to manage and remediate these threats as well. So as I mentioned before, source code management systems are no longer being used simply for managing traditional source code, but there's a couple things. Sensitive data, PII, PiPHI personal health information are often stored within code, within the comments of code, within sample of code, within various parts of code. But it is also being, a lot of this information are sitting in files that are in Git itself. So many well-known threat actors have targeted GitHub, GitLab, Bitbucket for credentials to internal data systems and the personal identifiable information itself. And developers often use these source code management systems as a private data store and frequently post sensitive data and PI in public repos. And those can be code, but also files and SQL backends to PHI. You guys might recall the largest financial services hack ever in Capital One. And the person that took all the assets of Capital One posted those assets in her public GitHub repo. So again, it's not code, but all this other sensitive information was sitting up in GitHub for people to be able to get access to and exploit. And files are often embedded or linked in that code that contain PII, and private repositories are just simply not enough. Hacking groups have frequently used brute force or credential stuffing, so to speak, to get into these private GitHub repos as well. So it's not just traditional code, it's not just infrastructure as code, policy as code, PII, PHI, other information that's actually being able to be exploited as well from from these source code management systems. There's a great example of this. A security researcher, again, another ethical hacker or white hat, recently found 200,000 health records leaked on GitHub through simple searches for credentials and PII. One example here was Waystar, which is a revenue management vendor for healthcare companies. And he found 6 repositories that had access to credentials for the clients of Waystar. The credentials provided access to their servers housing these EDI or electronic data interchange data with thousands of PHI records, thousands of these records. The researchers also found the password generation algorithm had a pattern easily cracked, all from code. And if you recall from like HIPAA, for example, every single violation of PHI exposed is subject to up to or in excess of $75,000 per incident. $75,000 per incident. And so people traditionally focused on database vulnerabilities or file-based vulnerabilities, but a lot of these are now shifting, and vulnerabilities are actually coming from code. So these are very real threats that are out there across the board, that are no longer threats in theory, but are threats in practice and are threats that are being exploited. Unfortunately, many of us, all of us, are subject to these different threats that are out there. And we just named the top 5 based off of our experience and speaking to lots of different experts that are out there. So what is it that we can go ahead and do about that? Let's talk about that in the next few minutes before shifting to questions. So let's look at some, a checklist as we go through these different threat scenarios that are out there. So number 1, we talked about secrets in code, credentials in code, passwords in code. So it seems obvious, but never hard code credentials in the first place, right? And a lot of times the way that this happens is that when you're creating test code, I've done it myself, You might hard code it, and you'd think that, okay, I'll switch this out and change it, right? But it either slips, you forget about it, you don't make the change, you're in a rush to meet, your sprint schedules, etc., and it just happens, right? There's now tools that are out there that many of you will be aware of, like HashiCorp Vault, other key management systems, key rotation systems that you can leverage, where you're actually not putting in the keys themselves, but references to the keys that are then put in at runtime, right? Companies please need to have secret scanning running in your code, whether it's SAST or RAST, runtime analysis, stack analysis tools, to empower your developers, your managers, to be able to identify where these secrets might leak in, and then be able to remediate them before they propagate. Remember, you check it into a repository, and then all of a sudden, or it gets cloned hundreds or thousands of times, and then that code is out there, it gets exposed into the public domain, and then you really have problems. And scan, that goes to being able to scan for this your code in public repositories, in public repositories, not just your own enterprise repos. If it's been cloned, it's probably in other places. It's probably already leaked, right? So you need to be able to make sure that you can contain the problem as close to the source as possible. So those are some of the strategies you can take in terms of secrets in code. Number two, this whole idea of the lack of visibility of where your code and where your clones are. So you want to monitor all the developer access, to code, and whether it's GitHub, GitLab, Bitbucket, including people's private accounts that are out there. So they'll have their corporate account, and you'll also want to look into and one level or two levels of indirection beyond that into their own accounts that are out there to make sure none of your code or clones of your code have made it out there as well. You want to have airtight access controls to Git for employees and contracts. Don't grant overly permissive access to sensitive code. It's just way too easy to access. So configuring or misconfiguring Git, it can either save you or kill you from the standpoint, right? And there's a lot of bells and whistles and knobs there. So you have to carefully create a level playing field in terms of the control plane for your source code and your source code management. And you can invest in tools that map your code assets, including those on your developer endpoints, to be able to have this kind of monitoring capability that are out there, right? And so that's very important. So secrets in code go hand in hand with gaining visibility into what your developers are doing, your contractors are doing, and don't forget about your contractors and your third parties that have access to this as well. It's not just your internal developers that are there. The last three in terms of like some in your checklist in terms of the threats that we covered. Open source. Don't just scan for known vulnerabilities. Also make sure that the source itself is authorized. So it's not just going through and saying, okay, hey, this open source came from someplace. Now I'm just going to scan it for vulnerabilities. You also want to have a trusted provenance or source of that code as well, and be able to enforce that and make sure that your developers understand that if they are, they're entitled to use open source, is great. But make sure that you're getting it from a trusted source. And make open source scanning automatically part of your developer and CI/CD workflow, and understand and invest in bill of material and solutions that will go ahead and tell you the provenance of that particular code. Now, the flip side of it is, we talked about as well, it's not just code that comes in, but you want to monitor open source for your enterprise code that might have leaked into open source as well. But the threat internally is from these outside packages that might have these Trojan horses in them. Number four, as we talked about, code is a blueprint for your infrastructure, for your policies. Infrastructure is code. So check for common Git misconfigurations, such as having a .git file available on your public website. That happens a lot more than you think. Don't forget about your third-party contractors, agencies that are managing different kinds of artifacts within your Git repositories. Ensure security can understand your code to work closely with developers, and all that goes for your infrastructure and your DevOps and your Devsecops teams as well. And invest in a security blueprint or an audit of your code in your environments to understand where you might have exposure in your infrastructure, and where infrastructure code, et cetera, right? And then it goes hand in hand with basically we're talking about understanding what's being managed in your Git repos and what's exiting. And PII and PiPHI in code is also extremely important to be able to understand what's in your code. So a couple of things to do there. First of all, it's not stated here, don't put PII or PiPHI even in comments in code examples, things like that. Enforce two-factor authentication across all your different developer accounts, like mail and not just in their Git services. Train developers in what the different PII, PHI, HIPAA regulations to ensure apps don't link or embed data. Don't forget about the third parties or agencies that you work with, and require an audit that all repositories are private and that all email and repo accounts have two-factor authentication. And one very well-known thing that happens in Git is the idea of being able to take a private repo and then making it public, right? And so if you do not have your permissions set properly, that's just way too easy to do. So it's important to get right. So again, these are the top 5. And just to review: secrets in code, lack of visibility into where your code is, the risk from open source, code serving as this blueprint to your entire operations, and then other things that you wouldn't think in code. There's PII and PHI in code. Look, our mantra is what we advocate is the world runs on code. And so for everyone, we want to make sure it's safe for our sakes, for our customers' sakes, for our user sakes, that we want to be able to do that. And things like Git and open source are great. We're not talking about blocking the use of this. We want to remove the friction of being able to use this. So you want to make it safe to use with Git. You want to make it safe to use with open source, and for all means, contribute back to open source. Just have visibility and to know what you're doing. But you got to protect yourself, from credentials, secrets, PII, PHI, and code, and make it, especially when it comes to intellectual property, make it safe from the theft and the misuse of code. And there are tools that are out there that you can leverage, to be able to help you going about. There's new sets of tools that are going out there. There's tools that we have, solutions that we have. Again, I promise this not to be a sales pitch, but the idea is that you should be able to surface security risks, have actionable alerts to be able to remediate, discover your blind spots and anomalies that might exist in code, understand your ecosystem, what developers have access to code. Are there developers that are accessing code that they shouldn't be accessing? Are they pulling from projects? If a developer quit or a contractor quit, why have they downloaded large chunks of code onto their development environments? Why is code been pushed out into these public environments? These are all important things to be able to understand and be able to surface, not just in your design, develop, and build phase, but all the way through to your deployment to production, and then continuously monitoring your code from that standpoint. So with that, I want to thank you all for your kind attention and listening to this, and I hope it proved useful here. And any of this kind of data you can get from us. Again, I'll leave my contact information up here. Please feel free to contact us. We have a security monthly digest that is we try to keep up to date to give you the most of up to date what's going up in the code security, and some of the reports that we reference in here as well we can make available for you. And I know the team here will also make our presentation and the video to this webinar available as well. So with that, I will go ahead and I will jump into questions if I can figure out how to make this this work. We have several questions here. Let me see if I can expand this and look.
Yeah, real quick, I just want to remind the audience that if you do have a question for Ajay, go ahead and use your GoToWebinar control panel and submit your questions. We have about 20 minutes or so, plenty of time for questions.
Yeah, I'm looking for, okay, I think I found some of the questions here. Okay, great. I'm just going through these ones here where we have some commonality. Okay, cool, great. Should developers be using some of these code security tools, or is it securities teams? It's kind of in the realm of security teams. That's a great question. So this whole notion of shift left, in terms of we're putting more and more into the hands of developers, anywhere from the code, how it gets deployed, how it gets in runtime, to infrastructure code and policies code. This needs to and must apply to security as well. So the earlier in the dev cycle that you catch and you manage for these security risks, the better. And it's definitely a mantra that should be followed more. So the earlier in the dev cycle to the individual developer where you can discover those secrets in code, any of the PII, PHI code, any of these different vulnerabilities, absolutely should be put in the hands of the developers. And you'll see that more and more. So a lot of different vendors that are out there now make this available to developers themselves and the tools. So they'll take their systems, allow for pre-commit hooks and the ability to look for secrets and do other things in the dev cycle prior to getting committed to master or push to master, or sorry, push to main or push to, before it gets into the production environment. So absolutely, source code security needs to go much more into the realm of the developers as opposed to just the security team. So that is a great question. From that standpoint. Another question that came up is how can companies prevent code theft by their employees? Are they at risk? So that's another interesting question that we've talked about here. So the important thing to realize here is that not all code, just like not all data is created equal, not all code is created equal. So there's going to be, if you have hundreds of thousands of lines of code, millions of lines of code, dozens of lines of code, whatever it is, a lot of that code might be seemingly innocuous from that standpoint, but there is that set of crown jewels, your AI code, your ML code, your trade models, your Python code, your R code, whatever it is, there could be that subset that's out there that's important. So it's, first of all, it's important to understand that not all code is created equal, that you want to be able to classify which code is more important than the others. And then for that subset of code, you can monitor more closely and decide whether or not that should be exfiltrated or not. Because a lot of times when people do things, they're not necessarily moving it around for nefarious places or posting for nefarious places, but they're trying to understand different bugs that they might have in their code and things like that. So you don't want to introduce friction as much as possible into the developer workflow or into the tool chain. So yes, you should classify your code and then map security policies to that code in a way that you can prevent the exfiltration of that code for the code that it makes sense. And there are emerging tools that allow for this so-called kind of code DLP that are out there that'll be able to help you be able to block that for that subset of code. So that's very important to do. Another question that has come up is, does GitHub, GitLab, Bitbucket, or other Git providers provide this type of security? So the answer to that question is yes and no. So if you remember and you understand how Git and you reference how Git actually works, is a lot of the different kind of controls that are happening around Git revolve around the source code repositories themselves, the centralized repositories. Where this stops, that security stops, is once someone's taken that code and they've actually cloned it onto their device. At that point, the various Git providers offer little to no kind of security on the developer machine, and certainly not once that code gets pushed into public repositories. So there has to, as people in cybersecurity talk, there's a series of controls or layers to security. Depth and breadth, we call it, right? So no one tool, no one system provides the breadth or the depth that's required for these different vulnerabilities that are introduced by code. So there's certain things that you can do in terms of configuring Git repositories correctly, two-factor, multi-factor authentication into Git. But once that code gets onto developer laptop, contractor laptops, into the external public domain, that's when it's all bets are off. And you need to supplement the tools that Git providers have with other tools that are out there, in the world for this to be able to happen. So GitHub, GitLab, Bitbucket alone don't provide the necessary breadth or depth that's required. So that's an important question. And I think the last question here that we can answer is where does code security sit in the app security stack? Does it replace code scanning tools like Veracode or White Hat Security, things like that? So excellent question. Excellent question. So remember, what we're talking about here is a supplement to these different kinds of tools. A runtime analysis, static analysis of code are absolutely critical to be able to locate vulnerabilities. Tools that analyze open source for their provenance of where that code come from and originate are absolutely important. Now there's a whole other class of tools that are coming in to be able to monitor what we call the extended universe outside of your enterprise of what's happening and where that code is proliferating to. what secrets are in code that might be in the public, domain, public universe. This is a whole complementary new set of source code security tools that are emerging to complement the tools that exist. And certainly they're not saying that there's a catch-all, but these types of tools are really there to be able to augment the kind of security tools and posture that you already have in place. So definitely leverage the tools that have been traditional tools that have been around for a long time, but there is a whole new class of solutions that have evolved because the landscape itself for security have evolved as well. So I'll answer with that. And I think, with that, that answers the questions that I see. I don't know if there were other questions that were posted. Let me see here.
Well, I will say that if you do have questions, please go ahead and get them on in. Right now, it looks like that is all the questions that did come in. But actually, there's maybe one just. Let's see. Well, somebody's actually asking you to talk about your product.
Yeah, I know there's a couple of questions that are about our product. I promise I wouldn't do a sales pitch, but I will say that if you're interested in our product, please contact us. But a lot of the different kind of threats that we have surfaced here are ones that we do address in our solution in our product, and we encourage people to look not just at us but at other providers that are out there. The idea here is that to promote the awareness of source code security, and code itself is a new surface area of attack that you have to you need to consider when you look at your overall security portfolio. I think I'll say that there's us, there's other emerging vendors. Definitely encourage people to go and explore what's out there. We're happy to help you and guide you as well. And please feel free to contact us. And again, thank you all for taking the time to listen, and really appreciate your time and your efforts here, and getting aware of this new problem that's emerging in this new space. Thank you so much.
Okay. All right. Well, we'll go ahead and keep the question box open. If you do have a question for Ajay, you can please, I encourage you to go ahead and use the GoToWebinar control panel. We'll keep it open, like I said, and I will just let folks just remind the audience that today's event is being recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. After today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. Then the webinar is also going to be living on the Security Boulevard website, so you can always go look for it there. Just go to securityboulevard.com/webinars, look in the upcoming section, and it should be right there waiting for you. Okay, we did have a couple more questions come in. Ajay, I don't know if you want to address them now. If you just want to go ahead and contact folks offline and get their questions answered, I'll leave it up to you.
So I'm happy to do this offline. And probably people can contact, and if we have the information, I think we have contact information. I'm happy to contact them as well.
You will be getting a copy of all of the questions that came in. So if Ajay did not address your question during today's webinar, you just heard him. He'll be more than happy to follow up with you guys offline. So do want to thank everybody who did submit questions. There were some really great ones that came in. So thanks again for that. And I did also mention at the top of the hour that we would be doing a drawing for 4 $25 Amazon gift cards. So without further ado, let's go ahead and do that. And then we'll give everybody a couple minutes back in their day. Our first winner today is Enrique P. Congratulations, Enrique. Our second winner today is Christy B. Christy with a K and B. Congratulations, Christy. Third winner today is Spencer L. Congratulations, Spencer. And our final winner today is Ken C. Congratulations, Ken. We'll be following up with all 4 of you offline via email to get your Amazon gift card over to you. So please check your inbox. If you don't see it there, please check your spam folder. Okay, Ajay, thank you so much for a great presentation. So much interesting stuff in there. I was really fascinated by the entire webinar. So thanks so much. I really do appreciate your time and your expertise.
And thank you to you and your team for hosting this. I really appreciate that as well.
No worries at all. And I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.